This question might look like partial fraction, but actually it's not. It's just simple algebra. So we can do is we can just multiply the right hand side, and it would be ax into x squared is ax cubed plus ax into 4 is 4ax. Then b into x squared is bx squared. Then b into 4 is 4b. Then plus we have cx plus d. Now if we arrange it in such a way that all the x cubed and x squared are arranged, so we can write ax cubed, then we can write bx squared, then we can take the x common, 4a plus c. We can take the x common, and the leftover are the constants 4b and d. So now we can compare. So for x cubed, so on the left hand side with x cubed we have 4, and here with x cubed we have a, so a equals to 4. Then for x squared, on the left hand side with x squared we have 2, and here we have b, so b equals to 2. For x, so here we have 17 with x, and here we have 4a plus c. Now we already know a is 4, so it is 4 into 4 plus c. Therefore 4 is 16, c equals to 17 minus 16, which is 1. And finally the constant, we have 8 over there, and we have 4b plus d. So we know 8 plus 8 equals to 4 times b is 2 plus d, that means d equals to 0. So we have found the values of a, b, c, d. Now in question number b, we can use those to just integrate. So we can write 1 to 4. Now instead of the expression that we have here in the question, we can just write in the other form that's given in part a. So we can write a, which is 4, 4x plus b, which is 2, multiplied by x squared plus 4 plus c, which is 1, so 1x, and d is 0. So divided by, we have x squared plus 4 dx. Now we can just simplify this using algebra, and it turns out to be 4x plus 2 multiplied by x squared plus 4 divided by x squared plus 4 plus x divided by x squared plus 4 dx. Now the first part, this and this cancels off, and we can just write it as 1 4 4x plus 2 dx. Let's separate it with the next one, 1 4 x squared plus 4 dx. Now it's very easy to integrate this part, 4x plus 2, but the difficult part is going to be the second part, which looks quite irregular. So let's do this first part. This is going to be 4. Integration of x is x squared by 2 plus integration of 2 is twice x. This is going to be 1 to 4 plus, now this part, there's a special rule for it, and the rule goes like that. When you have to integrate something that is a fraction, we usually think about, partial fraction, but this is a quadratic form that cannot be factorized. We cannot do partial fraction. We are stuck. In this situation, there's another format that looks like this: f prime x divided by fx. When we have that, it is going to be ln of fx plus c. This is the format. Now if we differentiate x squared plus 4, we are supposed to get 2x, but here we have x, the 2 is missing. We can change the format and write it in this format: half 1 to 4 2x x squared plus 4 dx, so that this 2 and this 2 cancels off, and this becomes the f prime x fx format. Now if you notice, this one is f prime x and this one is fx. So from the special rule of substitution, we can just write this as ln of x squared plus 4. So we can write, so this one is 2 cancels, we put 4. This will be 2 4 squared plus 2 4 minus 2 1 squared plus 2 1 plus half. This one is going to be ln of fx, so ln of x squared plus 4, and the limit is going to be 1 to 4. So here we have 16 into 2 is 32. 32 plus 8 is 40 minus 2 plus 2 is 4. Now here we have, if you put 4 over here, it will be half ln 4 square is 16. 16 plus 4 is 20 minus half ln 1 square plus 4 is 5. So we can write 36 plus, if we take the half common from here, it becomes ln4 minus ln5, which is ln20 minus ln5, which is going to be ln20 by 5, which is ln4. The law of subtraction becomes division. So the answer is going to be half ln4 plus 36. Now it's always a good idea to check what was the answer format that they asked for. So they asked for p plus lnq. So let's do a little bit of, so ln4 is 2 square, so we can write 2 ln2 plus 36. So this 2 and this 2 cancels. So the answer is 36 plus ln2. Done.